Hello students, in today's lecture we will study parallel plate capacitor. Completely filled with dielectric. So consider a parallel plate capacitor having plates P1 and P2. Positive charges are present on plate P1 and negative charges equal in amount are present on plate P2, and this plate P2 is connected to the earth. Again, let us suppose that small d is the distance between the two plates. Now here P1 and P2, two parallel metal plates having area A. D is the distance of separation between P1 and P2, or this can be written as the thickness of dielectric media between plates P1 and P2. Let us suppose that sigma is the surface charge density of the two plates, which is equal to Q divided by A. Due to charge on the two plates of the capacitor, let us suppose that V is the PD between the plates of the capacitor. Now the electric field intensity between the two plates of the conductor, suppose at point M, is directed from positive charge to negative charge, and this electric field intensity between the two plates of this capacitor is given by formula E is equal to sigma divided by epsilon, which is equal to sigma divided by epsilon 0 K. And this electric intensity expression is come out from the applications of Gauss theorem. The electric field intensity at a point near and outside the charged conductor is given by this formula. Again, we know that sigma is equal to Q by A. If this value is substituted in equation number 1, then we get E is equal to Q divided by A K epsilon 0. Suppose this is equation number 3. Again, the relation between electric field intensity, electric potential and distance is given by the formula E is equal to V by D. Say this is equation number 4. Then comparing the right hand side of equations 3 and 4, we get Q divided by A K epsilon is equal to V divided by D. So this expression is obtained by comparing the right hand sides of equation number 3 and equation number 4. And from this equation number 5 so obtained, we write next step is Q divided by V is equal to AK epsilon 0 divided by D. Suppose this is equation number 6, and the left hand side of this expression number 6, which is Q divided by V. By the definition of capacitance of capacitor, C is equal to Q by V, and therefore our final expression is the capacity of a parallel plate capacitor filled with dielectric is AK epsilon 0 divided by D. So here we use suffix small d, that means capacity of a parallel plate capacitor which is completely filled with a dielectric medium. So in between these two plates we have filled a medium having dielectric constant K, and the expression for electric capacitance of a parallel plate capacitor filled completely with the dielectric is given by this equation number 7, CD, that means capacity of parallel plate capacitor which is completely filled with a medium having dielectric constant K. Now from this expression we conclude that this capacity of parallel plate capacitor depends upon area, depends on dielectric medium, and depends on the distance of separation between the two plates. Or we may say that this capacity of parallel plate capacitor can be increased by increasing area of each plate, or by increasing the medium dielectric constant of the medium K, and by decreasing the separation between the two plates. So CD can be increased by increasing area of the plate, by increasing the medium which having higher dielectric constant, and by decreasing the space between the two conductors which forms a parallel plate capacitor. So as we have derived the expression CD, which is equal to AK epsilon 0 divided by small d. So this is the expression which gives the capacitance of parallel plate capacitor filled with dielectric. If the space between the parallel plate capacitor is filled with air, that means the space between P1 and P2 which forms the parallel plate capacitor is filled with air, then the expression for capacitance of parallel plate capacitor filled with air is given by formula Ca is equal to A into epsilon divided by D, because as the medium between the two plates is air, and for air K is equal to 1. So we have obtained the two equations, one with dielectric and another without dielectric, that means air medium between the two plates. Then from equation 1 and 2, we obtain the expression for CD divided by CA, which is equal to K. That means if equation number 1 is divided by equation number 2, then we get CD divided by CA, which is equal to K. That means dielectric constant of the medium. And from this expression, we write CD is equal to K times CA. That means capacity of parallel plate capacitor filled with dielectric is equal to dielectric constant times the capacity of parallel plate capacitor filled with air medium. So the conclusion from this expression is that the capacity or capacitance of a capacitor can be increased only due to the introduction of dielectric medium between the two conductors which forms the capacitor. It does not depend upon charge, it does not depend upon the PD between the two plates. So, in case of parallel plate capacitor, we have found the formula CD is equal to AK epsilon 0 by small d. Then, as we know that 1 upon 4 pi epsilon 0 is equal to 9 into 10 to the power 9 SI units. The value of epsilon 0 is come out to be 1 divided by 4 pi into 9 into 10 to the power 9, and which is equal to 1 divided by 36 pi into 10 to the power 9. Now this value is substituted in equation number 1. We get CD is equal to AK, value of epsilon 0 is substituted, which is 36, 1 upon 36 pi into 10 to the power 9, and the distance of separation is D. So this is another form of capacitance of capacitor filled with dielectric. Now, what is the effect of dielectric on capacitance of a capacitor? So as we have already seen, capacitance or capacity with dielectric is equal to K times capacitance or capacity of a capacitor which is filled with air. Again, in another way, this can be explained as the charge on plates of the capacitor, parallel plate capacitor, with air is given by the formula Q is equal to, as C is equal to Q by V, therefore Q is equal to C into V, so Q0 is equal to C0 into V0. Again, this can be written as C0 into V0 into E0 into again D, because E is equal to V by D, and therefore V is equal to E into D. So by using this formula, we have got the charge on the plates of parallel plate capacitor filled with air. Q0 is equal to CO into VO is equal to CO into E0 into D, because V is equal to E into D, so CO into EO into D. Suppose this is equation number 1. Secondly, the charge on plates of capacitor when filled with dielectric. So if the space between the parallel plate capacitor is filled with dielectric, then charge will remain the same, which is Q0. But Q0 is equal to capacity with dielectric multiplied by electric potential due to dielectric. Again, in the similar manner, we write as per equation number 1, CD into ED into small d. Suppose this is equation number 2. And from equation 1 and 2, we write CO into EO into D is equal to CD into ED into D. Therefore, this D and the small d gets cancels. Then we write CD is equal to CO into bracket E0 divided by ED. That means the capacity of parallel plate capacitor can be increased by the ratio of E0 upon ED. Again, it is known as dielectric constant of the medium. So this is the effect of dielectric on the capacity of parallel plate capacitor. Now, we will find the force acting between two plates of the capacitor. So our article is force between plates of parallel plate capacitor. So as we know that in case of parallel plate capacitor, there are two plates separated by small distance. On one plate the charge is plus Q, on another plate the charge is minus Q. And suppose this is the distance x, and we want to find the electric field intensity at point this P on plate P2 due to charges present on plate P1. And in order to find the value of force between the two plates of the capacitor, here we want to find the value of electric intensity. the electric intensity at a point P, which is on the charged conductor P2 having charge minus Q, and due to charges present on P1, we want to find the electric intensity, and that electric intensity is given by formula sigma divided by epsilon, which is equal to sigma divided by 2 epsilon 0 K. So, in case of parallel plate capacitor, the force between two plates separated by distance small r is equal to sigma divided by 2 epsilon is equal to sigma divided by 2 epsilon 0. This is by using Gauss application. And now the force acting on charge minus Q by plus Q, force on minus Q by charge plus Q is given by, as we know that E is equal to F by Q by the definition of electric field intensity, and hence the force is equal to E into Q, that is equal to minus the charge on the second plate is Q minus Q into epsilon divided by 2 epsilon 0 K. So this is the value of force which acts on two plates of a parallel plate capacitor. So this is the expression for force between two plates, which is given by formula whose magnitude is F is equal to sigma into Q divided by 2 epsilon 0 K. So force between two plates of the parallel plate capacitor is given by the formula F is equal to sigma into Q divided by 2 epsilon 0 K. Now, this formula or force between the two plates of the parallel plate capacitor can also be given by another formula, as we know that mechanical force per unit area, that is small f is equal to capital F by ds, is equal to 1 by 2 epsilon 0 K E square, and therefore force between two plates of the conductor is given by 1 by 2 epsilon 0 K E square into area ds. Or instead of area ds, here we write the area of either plate of the capacitor. And again this formula can be written as 1 by 2 epsilon 0 K E is equal to V by D, that means V by D is bracket square into area A. So this is the one of the form of force between plates of parallel plate capacitor. And again, if we substitute the value of E, so electric field intensity E is equal to sigma divided by epsilon 0 K. If the value of this E is substituted in this equation, again we get force between the two plates is equal to 1 by 2 epsilon 0 K into sigma square into A and divided by epsilon 0 square K square. So in this, 1 epsilon 0 cancels with 1 epsilon 0 and this K will cancels with this K, and the final form is force between the two plates is given by the formula 1 by 2 into sigma square into A divided by K. Again we know that sigma is equal to, as sigma is equal to Q by A, then this expression becomes F is equal to 1 by 2 Q square, sigma square is Q square divided by A square into this A and divided by K. Again this A gets cancels and therefore we get expression for the force between the two plates is, here epsilon 0 is remaining, F is equal to 1 by 2 Q square divided by A K epsilon 0. Here also epsilon 0 term is taken. So by using the expression for mechanical force per unit area of a charged conductor, we can define the expression for force between the two plates, and that force between the two plates comes out to be F is equal to 1 by 2 Q square divided by A K epsilon 0. Now, in this lecture, we will find the value of, again, force between the two plates in another form, and the force between the two plates can also be given by the formula force between the two plates F is equal to 1 by 2 CV square divided by D. So this is also one of the formula for force between the two plates of the capacitor, parallel plate capacitor. So in this lecture we have studied the parallel plate capacitor completely filled with dielectric. Again we have discussed about the effect of dielectric on capacity of parallel plate capacitor. Then we have find the various expressions for force between the two plates of the parallel plate capacitor. Now, if the two plates of the capacitor is partially filled with, suppose a dielectric having thickness small t is introduced between the parallel plate capacitor, and this dielectric has dielectric constant K. So when a dielectric medium is inserted partially between the two plates of parallel plate capacitor, then the value of capacity regarding this figure is given by the formula C is equal to epsilon 0 into A divided by D minus T plus T divided by K. So when parallel plate capacitor is partially filled with a dielectric medium having thickness T, then the new capacitance of this combination is given by formula C is equal to epsilon 0 A divided by D minus T plus T by K. Now, in second case, if the two plates of parallel plate capacitor are completely filled with a metal plate having thickness T, then what is the capacitance of this parallel plate capacitor which completely filled with the metal plate? And in this case, as the plates of the capacitor filled with the metal plate, the capacitance or capacity of this capacitor will become infinite. Or when the plates of the capacitor are connected with the metallic wire, then also the capacity of this parallel plate capacitor is infinite. Now we will take some numericals which are based on capacitor, concept of capacitor, capacitance, and parallel plate capacitor completely filled with dielectric. In this problem, we have provided an isolated sphere and its capacitance is given C is equal to 50 into 10 to the power minus 12 farad. And we want to find the radius of the sphere. And also we want to find the charge on the sphere if electric potential is given 10 to the power 4 volt. Then to find radius, we know that C is equal to Q by V, which is equal to Q divided by the electric potential due to sphere, which is given by 1 upon 4 pi epsilon 0 into Q divided by capital R. So C is equal to 4 pi epsilon 0 into R. This Q and this Q gets cancels. And by using this formula, C is equal to 4 pi epsilon 0 into R, we find the value of radius of the sphere, and which is equal to C divided by 4 pi epsilon 0. So R is equal to C. The value of C is 50 into 10 to the power minus 12. divided by 4 into 3.14 into 8.85 into 10 to the power minus 12. And if we solve this, we get radius equal to 45 into 10 to the power minus 2 meter. So the radius of sphere is 45 into 10 to the power minus 2. Then in second part we have asked how many charge should be placed to increase its potential by 10 to the power 4 volt. Again, to find charge, again we know that C is equal to Q by V, and therefore Q is equal to C into V. So which is equal to, value of C is 50 into 10 to the power minus 12, and the value of potential is 10 to the power 4, and we get the value becomes 5 into 10 to the power minus 7, and unit of capacitance is farad. Unit of charge is coulomb. So answer is Q is equal to 5 into 10 to the power minus 7 coulomb. In this problem, there are 10 to the power 12 electrons transferred from one conductor to another, and due to that a potential difference is developed which is 10 volt. And we want to find the capacitance of the two conductor system. So here N, that means number of electrons, are given, which is 10 to the power 12 electrons. Potential is given, V is equal to 10 volt. And we have to calculate the capacitance of the system. Again, we know C is equal to Q by V, or which is equal to, as we have learned in 11th standard, the value of this Q is equal to N into E, and divided by electric potential is V. Therefore, C is equal to N is 10 to the power 12 multiplied by E, that means charge on the electron, which is 1.6 into 10 to the power minus 19, divided by electric potential is 10 volt. And therefore, the capacitance of the system is 1.6 into 10 to the power minus 8, again unit is farad. So in this capacitor, the capacitor have their plates in the form of circular disc, and the radius of the circular disc is given, R is equal to 5 centimeter, 5 into 10 to the power minus 2 meter. Again, the distance between these two circular discs is given 1 millimeter, which is equal to 1 into 10 to the power minus 3 meter. And we want to find the value of, again, capacitance of capacitor formed by the circular disc. As we have studied, the capacity of parallel plate capacitor is given by AK epsilon 0 divided by D. But in this problem, the plates are circular disc, and for circular disc, area is A is equal to pi r square. So our formula is capacitance of capacitor having circular disc is equal to pi r square into K epsilon 0 divided by D. And if we substitute values in this formula, 3.14 into radius square, which is 10 to the power 5 into 10 to the power minus 2, which is become 25 into 10 to the power minus 4. Value of K is 1 and epsilon 0 is 8.85 into 10 to the power minus 12 and divided by the distance, which is 10 to the power minus 3. And if we calculate this, we get 3.14 into 25 into 8.85 into 10 to the power minus 13. And if we multiply all the terms, the answer comes out to be approximately 6.95 into 10 to the power minus 5 in microfarad. Or this answer initially comes out to be 6.95 into 10 to the power minus 11 farad. So in this problem, charge is given, which is 12 microcoulomb, which is equal to 12 into 10 to the power minus 6 coulomb. And V is given, which is 1200 volt. Again, we want to find the area, and we have provided dielectric strength, and this dielectric strength is provided, that means we have provided V by D, which is equal to 3 into 10 to the power 6 volt per meter. Then Q is equal to CV is equal to, value of C is AK epsilon 0 divided by D into V. Or we write Q is equal to AK epsilon 0 into V divided by D. And hence, if we substitute value of charge, which is 12 into 10 to the power minus 6, which is equal to A into K, value of K is 1, into 8.85 into 10 to the power minus 12, multiplied by V by D, and V by D is provided, which is 3 into 10 to the power 6. And from this, A is equal to 12 into 10 to the power minus 6 divided by 8.85 into 3 into 10 to the power minus 6. And this is equal to 12 divided by, or it is equal to 4 divided by 8.85, and which is equal to, or it is approximately equal to 0.5 meter square. So cylindrical capacitor is given and its length is given, which is 20 centimeter, and radii are given 1 centimeter and 1.6 centimeter, and charge given to the inner cylinder is 4 microfarad. So this problem is based on cylindrical capacitor. So in this problem we have provided L is equal to 20 centimeter equal to 20 into 10 to the power minus 2 meter. Again, radii of inner cylinder is Ri, which is 1.5 centimeter, 1.5 into 10 to the power minus 2 meter. The radii of outer cylinder, which is 1.6 centimeter, 1.6 into 10 to the power minus 2 meter, and charge is given, which is 4 microcoulomb, 4 into 10 to the power minus 6 coulomb. And we have to find the value of C. So, the capacity of or capacitance of cylindrical capacitor is given by 2 pi epsilon 0 K into L divided by 2.303 into log of Rho upon Ri to the base 10. Now, if we substitute the values, the C is equal to 2 into pi 3.14 into epsilon 8.85 into 10 to the power minus 12, K is 1, into length is 20 into 10 to the power minus 2, and whole divided by 2.303 into log of, so here Rho upon Ri is nothing but 1.6 divided by 1.5, and this ratio is come out to be 1.066. So the log of 1.066, and by calculating this we will get 6.28 into 8.85 into 2 into 10 to the power minus 13 and divided by 2.303 into the log of 1.066, and the log of 1.066 is come out to be 2.775 into 10 to the power minus 2. And if we calculate its value, then its value comes out to be nearly 17.70 into 10 to the power minus 11 Farad.